Welcome to Zoom in Data. In this session, we will discuss Databricks Autoloader, also known as CloudFiles, which is a powerful feature used for incremental data ingestion from cloud storage. Autoloader is widely used in real-time and near real-time data pipelines and is a very important interview topic for data engineering roles. Understanding Autoloader helps engineers design scalable, reliable, and efficient ingestion systems without complex file tracking logic. This subtopic focuses on both conceptual clarity and interview relevance. Key points covered in this subtopic: purpose and working of Databricks Autoloader, incremental file ingestion and scalability, schema inference and evolution, interview-focused concepts and best practices. Subscribe to Zoom in Data to continue structured learning of Databricks concepts. What is Databricks Autoloader? Databricks Autoloader is a managed ingestion mechanism that automatically loads new data files from cloud storage into Databricks. It is designed to process only newly arrived files without reprocessing previously ingested data. Autoloader simplifies ingestion by removing the need for manual file tracking logic. It is widely used in production pipelines for continuous and large-scale data ingestion. Why is Autoloader preferred over traditional file ingestion methods? Traditional ingestion methods often require custom logic to track processed and unprocessed files. Autoloader automatically handles file discovery and tracking in a scalable way. It significantly reduces operational complexity and engineering effort. This makes pipelines easier to maintain and more reliable in production environments. Which cloud storage platforms are supported by Autoloader? Autoloader supports major cloud storage systems such as Amazon S3, Azure Data Lake Storage, and Google Cloud Storage. It integrates natively with these platforms to ensure efficient data access. This allows organizations to ingest data directly from their existing data lakes. Cloud-native support ensures better scalability and performance. How does Autoloader identify new files for processing? Autoloader keeps track of files that have already been processed using metadata. It continuously monitors the storage location for newly added files. Only new files are picked up for ingestion in each run. This approach prevents duplicate processing and improves efficiency. What is file notification mode in Autoloader? File notification mode uses cloud-native event systems to detect new files. Instead of scanning directories repeatedly, Autoloader receives file arrival events. This approach reduces latency and improves scalability. It is the recommended mode for large-scale enterprise pipelines. What is directory listing mode in Autoloader? Directory listing mode works by periodically scanning storage directories. It compares existing files with previously processed files to find new data. This mode is simpler to configure but less scalable than notification mode. It is suitable for small datasets or low-volume ingestion scenarios. Is Autoloader a batch or streaming ingestion tool? Autoloader is built on top of structured streaming in Databricks. It processes data incrementally, similar to a streaming pipeline. At the same time, it can be used for batch-style ingestion use cases. This flexibility makes it useful for a wide range of data pipelines. What file formats can Autoloader ingest? Autoloader supports commonly used file formats such as CSV, JSON, Parquet, Avro, and awk. It can automatically understand the structure of supported file types. This allows engineers to ingest diverse datasets without complex parsing logic. Format flexibility is important for real-world enterprise data sources. How does schema inference work in Autoloader? Autoloader can automatically infer the schema from incoming data files. It identifies column names and data types based on file contents. The inferred schema is stored and reused for future ingestion. This reduces manual effort during pipeline development. What is schema evolution in Autoloader? Schema evolution allows Autoloader to handle changes in data structure over time. When new columns appear, Autoloader can automatically update the schema. This prevents pipeline failures due to schema mismatches. Schema evolution is essential for handling real-world evolving data sources. How does Autoloader handle very large numbers of files? Autoloader is designed to scale efficiently even with millions of files. It uses optimized metadata management instead of full directory scans. Performance remains stable as data volume grows. This makes it suitable for enterprise-scale ingestion pipelines. What is the role of checkpointing in Autoloader? Checkpointing stores the state of processed files and ingestion progress. It enables Autoloader to resume processing after failures. Checkpoints ensure exactly once data processing semantics. This is critical for building reliable production pipelines. How does Autoloader ensure fault tolerance? Autoloader uses checkpoints to track ingestion progress safely. If a failure occurs, the pipeline resumes from the last successful state. Already processed files are not reprocessed. This ensures data consistency and reliability. How does Autoloader integrate with Delta tables? Autoloader commonly writes ingested data into Delta tables. Delta tables provide ACID guarantees for ingested data. Streaming writes are handled efficiently and reliably. This combination is widely used in lakehouse architectures. What is the difference between Autoloader and copy-inter? Autoloader is designed for continuous and incremental ingestion. Copy-inter is typically used for batch-based ingestion. Autoloader is better suited for near real-time data pipelines. The choice depends on ingestion frequency and pipeline requirements. How does Autoloader improve ingestion performance? It avoids scanning previously processed files repeatedly. Notification-based ingestion reduces file discovery overhead. Parallel processing improves throughput. This results in faster and more efficient pipelines. What are common use cases for Autoloader? Autoloader is used to ingest logs, events, IoT data, and clickstream data. It is commonly used for raw data ingestion layers. Enterprises use it for continuous ingestion pipelines. It supports both real-time and near real-time analytics. How does Autoloader support near real-time ingestion? Autoloader continuously monitors storage locations for new files. Data is processed shortly after files arrive. Notification mode minimizes ingestion latency. This enables timely analytics and reporting. What security considerations apply to Autoloader? Access to cloud storage is controlled using IAM roles or service principals. Permissions determine which files Autoloader can read. Security policies of the Databricks workspace are enforced. Proper security configuration is essential for production environments. What type of interview questions are asked about Autoloader? Interviewers often ask about incremental ingestion concepts. File discovery modes and schema evolution are common topics. Fault tolerance and checkpointing are frequently tested. Real-world use case explanations are highly valued. What are best practices when using Autoloader? File notification mode should be preferred for large datasets. Checkpoints should always be configured correctly. Schema evolution should be enabled carefully. Pipelines should be monitored regularly. How does autoloader scale with increasing data volume? Autoloader scales efficiently as file volume increases. Metadata tracking prevents performance degradation. Cloud-native design allows elastic scaling. This ensures long-term pipeline stability. How is autoloader used in enterprise environments? Enterprises use autoloader to simplify ingestion pipelines. It reduces operational overhead and manual intervention. Pipelines become easier to manage and scale. This improves overall data engineering productivity. What limitations should engineers be aware of when using autoloader? Proper storage permissions must be configured in advance. Schema changes should be monitored carefully. Long-running streams require monitoring. Correct configuration is important for optimal performance. Why is autoloader important for Databricks interviews? Autoloader reflects real-world data ingestion knowledge. It shows understanding of scalable and reliable pipelines. Interviewers value candidates who know production tools. Mastery of autoloader increases interview confidence. Thank you for watching Zoom in Data. If you found this video helpful, like, share, subscribe. More Databricks interview and tutorial videos coming soon. Stay connected and keep learning with Zoom in Data.